All right, hello and welcome to episode 3 of our LinkedIn Live series. Today we'll be talking about project management and how we can increase our returns on investment through managing our projects better. First of all, an introduction of myself. I'm Colin Newberry. I am the Director of DevSecOps at Yahara Software. I have about 2 decades of experience in this field, working with international systems, Fortune 500 companies, US government systems, including my work with Third Special Forces Group, where I managed international teams across the globe. All right, so today's episode 3, we're working on project management. Next week, we'll be talking about a case study on disaster recovery and how we can use the principles we've talked about so far in reducing our cost of disaster recovery. And then finally, week 5, we'll be talking about waste management in the cloud. All right, to recap what we've talked about previously, nothing works without a strong foundation. If we don't build out our foundation first that we explained in episode 1, everything else will collapse. So before we start any kind of transformation, we need to have a well-documented organization structure. This isn't just some chart with bubbles. This is a clear set of reporting lines with known responsibilities and key stakeholders and customers identified. Your organization chart critically must identify who the consumers of your DevOps practice are. Without that information, we can't have a clear decision framework. In order to make good choices, we need a decision framework that is built off of an organizational understanding. So the authority for what decisions can be made at what levels, removing ambiguity from the decision framework, and putting in place timelines and expectations for how decisions should be made. One of the most expensive things that I've seen in DevOps transformation with organizations I've consulted at is decision paralysis. And normally, this is caused by fear of making the wrong decision. But at every one of these organizations, I can tell you from experience, no decision cost far more than a wrong decision would have. Next, we need comprehensive style guides. Style guides, in our case, are used to keep everybody writing their infrastructure code to the same standard. This is going to help with maintainability. It's going to help with onboarding new engineers. This should be something that is specific to how you expect your organization to use the tools that are prescribed. This is not intended to constrain engineers. This is intended to allow for responsible innovation. We should be giving people left and right limits and allowing them flexibility within those limits. Allow them to innovate and be creative within the standards and the expectations of the organization. And finally, foundationally, we need to have a clear onboarding process. As I'll talk about later on in this session, a transformation of your DevOps practice is not a quick process, and you don't want to be stuck onboarding new engineers without a clear onboarding process. One of the most painful things to have happen to a team is to give them an engineer who is not set up for success and expect them to fend for themselves. You will set your teams up to fail if you do not set up individuals for success. So once you have your foundation in place, it's time to start building some structure around it. So we have our microservices architecture that I promoted in session 2, building small single purpose code libraries, giving teams the ability to work on different components without risk to each other's code, avoiding major releases where you're having increased risk, and being able to actually adopt real CI/CD in your infrastructure. So why does this work inside of IAC? Well, IAC is actually built on top of components that are already discretely segmented, right? A router is a router. A router doesn't care about how you hypervise virtual machines. A virtual machine is a virtual machine. It does not care about how you provision your switch. A switch is just a switch. It does not care about how you provision your storage. All of these things work together through clear inputs and outputs. And that is exactly how microservices are designed to work. Microservices also bring us the power of reuse. Traditional monolithic infrastructure as code playbooks do not have reuse. They have reproduction. Every time we start a new project, we reproduce all of the lines of code into a new playbook, and we double the amount of maintenance we have to do. Every time we have a new project, we increase the number of lines of code we have to maintain by the same amount that we are already maintaining. With microservices, all of the maintenance of lines of code is done at the remote microservice repository. Each project composes the already written, tested, and maintained microservice modules into a template that they use, which is typically between 40 and 60 lines of actual code that is used to deploy an entire environment, meaning that one maintenance budget covers the entire company's infrastructure. So with that, what is the problem? Why are we trying to tackle an issue here with project management now? We've already talked about the foundational requirements. We've talked about the architectures that will work for us. Why do we have to talk about project management? Why can't we just do it? Well, to put it simply, this isn't a green field. We aren't coming at this problem from day one. Very few organizations who are attempting a transformation are doing a transformation because they started out with everything perfect, right? There are startup companies out there that have zero infrastructure who can do this from day one. Most of us are building off of decades of already established data centers. And those already established data centers may also have decades of attempts at infrastructure as code, some of it working, some of it not. We're going to have decades potentially of piled up technical debt. And this is why we need good project management to be able to manage and move forward. With our production infrastructure, our customers do not tolerate outages, right? There are a lot of options these days. There are very few, if any, niche companies out there who really have the only option for their field. Most companies are in a highly competitive field where any downtime, any pain perceived by a customer will result in that customer looking for a different service provider. Transformations take time. This isn't an overnight thing. Most organizations I work with will find that it takes a minimum of 12 months to do a proper transformation, usually closer to 18 to 24, depending on the size of the organization and how long they've been in business and how much infrastructure they've accumulated. That requires some pretty clear expectation management. And with those expectations, we need to maintain visibility. Because if we lose visibility from our stakeholders, our transformations won't just fail, they'll just die off. They'll get canceled for other priorities. It requires a pretty significant investment up front. Now, I'll be clear, the investment for this isn't generally going to be a large financial investment of new capital. This is a reorganization of existing investment with a relatively small investment and potentially in new tooling. The largest part of this is your engineer's time. For a good transformation process, you're going to have to expect to spend a minimum of 20 to 40% of your engineering capacity on transformation. And this has to happen while still maintaining all of your existing infrastructure. The next expense we have on here is training. Engineers likely will need new training to be able to cope with the new patterns that are being promoted here. Most engineers are trained on monolithic infrastructure patterns. And to understand the benefits and the way to code good microservices, they will likely need new training. There may be some additional tools required if you don't already have CI/CD pipelines. CI/CD pipelines, when building microservice modules, become very important because they allow you to automatically test every single module before it gets released. And you can standardize your testing to ensure that all of your code is acceptable before it ever gets consumed. And the last major investment here is risk management. Risk management is a relatively expensive process from a time perspective, primarily, as we have to identify all of the risks that we may face for the extended period of the project. Right? This isn't something where you're going to be easily able to go in there and say, yes, this is exactly what we're going to have happen. These are all the things that could go wrong. This is a pretty concerted effort, and it may require some additional consultants from external to the company if you don't have people internally who are experts in managing these types of risks. So once you've got that understood, we can start and start at the beginning. Don't try to start where most organizations do, which is looking at the outcomes. Don't look at the outcome you want first. Look at your foundations. Build up a foundational roadmap first. Start by mapping your current state. You cannot possibly understand how to get to your destination if you don't first understand where you are today. Map out your entire infrastructure. Figure out the technical details of it. What is it? Is it compute, networking, storage? What cloud provider or data center is it in? What infrastructure as code tools are you using to manage things today, if any? You may actually find that you have 3 or 4 different non-standardized tools being used across your infrastructure to maintain things. And these are normally caused by native transformations that have happened over decades of infrastructure deployments. You may have started with Jenkins and then moved on to Chef and then found that Chef didn't quite meet your needs anymore. So now you went to Terraform. But all of that old compounded infrastructure as code never got transformed into the new systems. Put some business context around your infrastructure. What is this actually supporting? What business function are you supporting with each component? Who is responsible for it? These could be teams or individuals. Who are the consumers? The consumers are very important to us because we cannot make good decisions if we don't know who's impacted by them. And then, are these business critical? Is this a mission critical system that if it has an outage, we will lose customers? Is this something that's kind of important, or is it really just a nice to have? Wrap some operational context around that. When was the last time it was updated? Do we have known issues or technical debt on this infrastructure? Do we have known dependencies that we need to consider if we start to transform it? And does this need to be compliant with any security requirements? Are these HIPAA? Are they PCI, SOC 2? And then finally, equally important to everything else, understand the financial impact of each one. What is the current monthly cost? What have been the cost trends? Are they increasing, decreasing, or staying flat? And who actually owns that budget? Whose budget is being impacted when that infrastructure exists? If that cost goes up, who is going to pay for it? When you do this, you're going to identify a lot of early quick wins. And the intuitive thing to do here is try to tackle the quick wins as quickly as possible. However, I'm going to tell you right now that visibility of your transformation is far more important than an early impact. All right. You can easily, over the course of an 18 to 24-month project, lose your stakeholders' interest. Having quick wins scheduled throughout your project, things that you identify in this first foundational phase that you can schedule as you're working through different components of your architectures, is going to help you maintain visibility and keep stakeholders understanding the value of the work you're doing. Orphan resources, duplicate functionality, and over-provisioned resources are the most common examples I see in these types of projects where we can very easily schedule out these wins to maintain visibility and keep stakeholder buy-in. Next, we're going to identify any risks that are inherent in the current infrastructure that we've mapped out. We need to understand compliance gaps that we currently have, which may be blocking potential revenue, right? If we are waiting on a SOC 2 to be able to unlock some enterprise revenue, let's identify those compliance gaps and let's prioritize those as part of the transformation. Find ways to tie the transformation back to potential revenue and other dependencies that the business is waiting on. Look for critical dependencies that might not be documented. These are the inherent infrastructure risks that you're going to tackle that are going to prevent loss and increase revenue and provide more value for your transformation. Lastly, we're going to group everything. And there's 5 categories that I prefer to group things into. The first is by architectural pattern. And when I say architectural pattern, I mean, what type of architecture are we supporting? Is this a web application, a data pipeline, batch processing job, or something else? If we understand our architectural patterns that we support, it's going to help us make better decisions as to what to upgrade together. Technology stacks are also important to understand, so we should know if we were doing databases, are they Postgres, are they MySQL, are they MariaDB, what are they? If you're using containerization, are we in EKS, ECS, Fargate? What are we transforming? Team and organization. Who actually owns what you're going to be transforming? If you have 5 teams in your organization, all of them may use virtual machines, but you don't want to transform all of their virtual machines at once. You want to iterate through each team. Start with a low impact team that has the ability to provide more feedback. Once you've worked through that one, getting to the second team will be far easier. Group these also by age and quality. You might find that you have legacy infrastructure with significant amounts of technical debt that is going to be actually more beneficial to replace during the transformation rather than to transform and try to tackle that debt. And finally, by compliance requirements. And I do have compliance requirements last here for a reason. If you try to tackle everything that's in your PCI DSS scope at once, it is going to fail. It is biting off way too much and way too large of a variety of infrastructures in one group. Next, we have to understand principles of a good transformation project, right? So we have 6 principles here that we manage our projects to, and these are foundational to everything we do. First, always build your foundations before your features. Don't touch code until you understand the organizational foundations that are going to guide your work. If you don't have a style guide, then everybody's going to be working in different idiosyncratic methods on the code, and you're going to end up with a mess in the end. Principle number 2, always pilot before you scale. It's pretty obvious. Bite off small chunks, do something non-critical, test it in non-production environments before you try to deploy into production. Principle number 3, measure everything. When you're trying to maintain buy-in from a stakeholder, it's very difficult to do if you cannot prove the value of what you're doing. Measure everything from day one. You may not use everything that you measure when you're doing your reporting, but keep every measure that you can, because in the end, it's going to help you with your reports when you try to figure out your final ROI for the transformation and justify all the work you've done. Principle number 4, communicate constantly. When I talk to executives, board members, and other stakeholders at organizations who are going through transformations, their largest complaint is not the cost, it's the lack of communication. You should feel like you are annoying them. I promise you, you're not. There should be daily touch points, whether it's a Slack or Teams message or just an email to say, hey, we did something, here's what we're doing next. Have some weekly touch bases, monthly status reports, but make sure they are staying engaged. If they feel like they are part of the process, they are much more likely to continue to support you throughout your entire transformation project. Principle number 5, Build and maintain momentum, right? Those quick wins, don't do them all at once up front. It's going to have more business value in the end if you do it all up front, but you're going to lose visibility, you're going to lose momentum, and you're going to lose the interest of your stakeholders. They're going to find something shinier and newer to look at, and then they're going to pivot away from you. And finally, but most importantly, accept imperfection. Version 1 should not be perfect. Create version 1, ship it, test it, learn, and iterate. Create version 1.1, add a new feature. Continue to work on shipping, learning, and iterating throughout your transformation. I mentioned that transformations are a long project. This is not something that happens overnight. This should be done in a phased approach. And this next slide is very wordy, and I don't apologize for that because it needs to be wordy. This next slide here is a list of core deliverables that you need to have by the end of your first phase. When you build out your foundations for your project, you should have all of these deliverables defined. You need to have your organizational charts with roles, responsibilities, and reporting lines. Otherwise, you can't really build off of anything. You need to have your full inventory of all of your infrastructure. If you don't know where you're starting, how can you possibly get anywhere? You need to have your mapping of business applications to the infrastructure services so you know what teams and what value you're going to impact as you do your transformation. You need to have your decision guide, prevent ambiguity, prevent decision paralysis. Decision guides should also include timeline expectations based on categories of decisions that need to be made and who needs to be making them. Escalation procedures for complex decisions or decisions that have become stalled. You need an onboarding process. One of the hardest things to do in the middle of a transformation is onboard a new employee. If you don't have a clear, structured onboarding process, this is going to stall your entire project. And let's be clear, there are people who are going to leave during transformation. A lot of engineers have emotional ties to the code they've written, and they don't want to transform to something new because they are emotionally attached to what they've done. A lot of work is put into getting to where they are today, and they may not like the idea of transforming. Infrastructure needs to be grouped. Get your groupings done, the patterns, the functions, however you're going to group it so that you know the order you're going to tackle your transformation in. Have a detailed plan for each functional group. Don't just have vague, we're going to do this. Have actual detailed plans laid out on a timeline with clear deliverables and milestones. Create module requirements per group. And this is where you're going to start to actually see the value of this pattern. As you create your module-based requirements for each group, you're going to find that each successive group is going to reuse modules that were already written previously. And the net new code that you have to write for each new group of resources is going to reduce as you go. Map your dependencies, make sure you understand what's going to be impacted by what upstream and downstream. And finally, do your risk assessment before you actually touch any code. Phase 2, build your code library. Now we're going to actually start putting hands-on code. So identify your high impact modules first. Where are you going to get the most bang for your buck? I typically recommend that people identify 5 of their most used services, figure out what the logical deployment patterns those fit into are, and then working within your foundations that you built in phase 1, start building out your modules. Once you get those 5 modules written up, start composing them into templates. Don't write new code for these modules and these templates. Compose the existing modules through configuration into templates, which looks a little bit like this, right? So here is an example of an RDS Postgres module. So this is taken from a README file that we have for implementation. The basic use case should work for nearly all of your projects, at least at the development level, right? You should be able to simply deploy this and start up a project. And then as the project grows, you can add customizations. The customizations do not require any new code to be written because those customizations are already baked into the modules themselves. And these are flags that are set downstream in the templates to be able to consume those various module parameters. So here's what that actually looks like in practice on a template. So this is a basic compute template with a standardized AMI. So this is an AWS. We're using a well-defined VPC with networking. We have an EC2 instance, and we have an application load balancer, which is a little cut off at the bottom because the screenshot was too small to read. But you can kind of get the idea here. There are a clear set of required parameters. There's variables that are set. These are used for building out naming conventions, tagging, and if you're building your module as well, these environments will actually set default values based on the environment that they're being deployed into. And then there are some dependencies from other modules that are pulled in automatically. This deploys. This actually works. There's about 45 lines of code in this environment, and it will deploy a full environment. And notice those sources. The sources here are our remote modules. We are not building resources in the template. So with prefabricated building, this is an analogy I like to use here. In construction, we do a lot of prefabrication, right? So we build high quality components at a factory offsite. We ship those components to the construction site and we assemble them in place. Once they've been assembled, we can do customization on site. Very similarly here, I have a screenshot of an application load balancer module. So we ship the application load balancer module to the team with the basic dependencies and necessary variables to perform the tagging and environment deployments. Then that team decides, well, we want to have both HTTP and HTTPS enabled and our default target group. All they have to do is use the Boolean flags to turn those on. We don't have to write any new code. With every single module and every single template, there are testing requirements that we need to follow. Every module should be fully tested and confirmed to be working before a release is created. In the second episode of this series, I talked a fair amount about versioning releases for all of our modules. During your transformation, you need to make sure that you are testing every single one of those modules. When you get to building templates out of those modules, you should be doing integration tests. Every day, you should test deployments in a pipeline. So before a release of a template is created and shipped off to a project team to use, you should have already confirmed that the basic configuration will deploy without any errors. Once we get into phase 3 of our transformation project, we are going to start working at scale. So at this point, we can start working on multiple groups at a time. We've built our foundation. We've built a few modules out. We've got a template, at least one, and now we understand the process. We can start to transform multiple infrastructure groups in parallel now. This works because we have established governance processes and maintenance processes for our modules. Every module is built with native interoperability, and we're deprecating the old patterns and consolidating into our new patterns. As we do this, we can measure and report on the ROI that we're receiving from our transformation. We can do parallel project implementations because microservice modules are truly reusable. We do not reproduce any code. Every project is going to use the same remote module, and it's going to simply be deployed and configured for each project. That means we are actually going to build our code once and reuse it many times, which is a huge savings for our projects. This is where we start to see real tangible value. In monolithic architectures, we may be maintaining tens of thousands of lines of code. In microservice architectures, we are only maintaining code in one location. Monoliths, we have it in every single project. So if we have 10 projects by 10,000 lines of code each, we're maintaining 100,000 lines of code. In microservices, 10 projects, that same 10,000 lines of code is maintained once in one location, and it's composed into each of the projects with 40 to 60 lines of code each. Of course, more advanced projects may have more, but again, we're just doing composition. We are not doing new code development at the project level. Governance is really important in this case. In order to make sure things work across multiple projects, this is where there's often a sticking point, right? So project one, it may work perfectly for. You get it project two, and you start rolling it out to them, and you might find that they have different edge cases that need to be accounted for. That's great. Create a review cycle. Bring that back in. Modules should not be stale. These should be constantly being evaluated and reworked. Get that feedback from the teams and create patches, minor releases, and if necessary, a breaking change. Measuring everything, as I mentioned before, is key to success, right? We can do all the work, but if nobody understands the return that they're getting from the investment, we're going to lose the interest of our stakeholders and they're going to move on to something else. And with the length of time this type of a project takes, we're going to lose the project. Documentation is a measurable thing. Style guide conformance is measurable. The percentage of projects that are being standardized on a single set of tools. How much you're actually reducing your expenses through your quick wins throughout the life cycle of the project. How many modules have you converted? How many templates have been created? What is the decrease in time to deploy with new templates? And what percentage of projects are now using your templates and modules from the transformation? These are all really important measures that can be used to show actual tangible value. Phase 4 is where we start moving into our optimization. This is where we complete the remaining legacy infrastructure patterns, transform what's left, optimize the modules that have already been written, continue that feedback loop, keep getting information back from your stakeholders and from the project teams that you're deploying to, and optimize those. Establish a process for continuous improvement. Just because you've completed your initial transformation project doesn't mean you should stop working on that infrastructure. It should be a continuous living thing. And then you can finally start focusing on the advanced patterns that your engineers are probably a lot more excited about. Multi-region, multi-cloud, disaster recovery. These are the things that your engineers actually want to be doing once they can actually do it. They don't want to be sitting here maintaining an insurmountable mountain of technical debt. They want to be doing advanced things that can show real value. So finish your main body of work. Make sure that you are not leaving anything behind. All services need to be modularized. Continue to optimize those modules based on your feedback. Address any failing automated tests and make sure that those tests are actually appropriate for the level that they're at. I've seen organizations try to do a little bit too much of advanced testing on the module level. And maybe that's not appropriate. Maybe that module can't be deployed that way and tested that way until it's actually included in a template. Take these into consideration when you're going through your automated tests. They might not be failing because your module isn't written well. It might be failing because the test is being performed in the wrong location. And establish your process for continuous improvement. Again, DevOps workflows after your transformation need to continue. But wait, what if I don't want to transform everything? What if I don't feel like boiling the ocean, right? Smaller projects should follow the same framework. This isn't just a framework for transformations. This is a framework for any project that you're doing in DevOps. Anytime you're trying to tackle a DevOps project, whether it's transformative or if it's a new functionality, you should be having clearly established foundations. You need to have principles for success that everybody understands. You need to have measures that you can use to prove value of your work. Iterating to completion. No matter how small the project is, version 1 shouldn't be perfect. Spread your quick wins out and maintain stakeholder confidence. It doesn't matter the size or scale of your project. These same things are important for anything you do. So now your transformation's in motion, right? We've got this going. We've started to see some real returns on our investments into our foundations that we've been building. And at this point, we've planned out our roadmap. We are on our way. We've got our prefabricated components. We may have all of our infrastructure modules written at this point, and we're starting to transform the real infrastructure. So what are we going to do next? We're going to start tackling some of the more advanced things that we can do with this pattern. One of those that is very impactful for most businesses is disaster recovery. For anybody here who has worked in disaster recovery, you know that cold sites are a very risky way to manage your disaster recovery posture. But if you are doing microservices properly, that isn't really the case. A cold site can actually be equally as reliable as a warm or hot site. So we'll talk more about that, and we'll do some demos of that in our next session. Thank you very much for your time and for joining me for this LinkedIn Live session. And hopefully I will see you again next week.